Hi everyone, my name is Ademola Ibironke, and I'm here to do a short presentation of a project that my colleague Van Dan have titled Cultivating the Cultivated Areas of Texas. This project is just to show how a Python um, can be used to do data analysis of some peculiar kind of data, in this case, the raster data, to for different purposes. And for this purpose, we are trying to calculate or determine um, just what size of Texas, the land cover of Texas is determined or is can be described as the cultivated area of Texas. Um, so this I'm presenting this on a Jupyter notebook, and there is a general outline of how we have how we've gone about this project. I'm going to start over here just to show what the problem statement is. It's numerically calculates the cultivated area of Texas state from an IMG file that was derived from National Land Cover Database. I'm going to show what the database looks like. So over here is where the source of the data is. We downloaded um, the data from this website of National Land Cover Database, and we selected Texas. Um, and what we're trying to do is to show from that data, analyzing that data, and show how we are able to determine what part of the land cover of Texas is cropland or cultivated land. As you can see on this website of MRLC, the the planted or cultivated land area is actually classified by the number 81 and 82, and we are going to show how we use that um, in our code and in our determination. So, in order to read this raster data, we had to import libraries, and we're basically using the gdal library from Python. We imported the gdal library as well as NumPy, and in order to plot the results that we generated from this calculation, we also imported the matplot library um, for that purpose. Just to provide a little more background to this project, we are working with a raster data, which is mostly um, image data that requires a particular um, method of analysis. And so, in order to first of all be able to read the data, we have created a file. So the data was downloaded on a on the computer hard drive, and we had to create a directory for this program. In this case, the Jupyter Notebook program to read the data. And so over here, I'm showing how we have assigned this object that is named file as the file name, as a directory to which the computer can access that data. And so because we have imported the gdal library, we are able to open that data using gdal. And so we assigned NLC as the name of the open file. So once we are able to open the file, we already know that the data is going to be read as in form of a spreadsheet. It's going to have values and it's going to have columns and rows. And so we've assigned the letter A as an object for which all the values in our rows can be read, and the letter B is representing the columns of the data frame. C is going to be um, a multiplication of A and B just to show the entire, for us to determine the entire area or the entire size of the data. So printing C over here shows that we have 44,224 cells because raster data is actually designed as cells, and so we have 44,224 cells in our row, and we have 41,260 columns. In order to calculate the total pixels of this raster file, um, we have to be multiplying, you know, the row and the column, and that's what this line is showing over here. And so the total pixels of this raster is this number 18259200040. I want to quickly show what that data look like on QGIS. And as you can see over here, it has several layers that are numbered from 0 to 25. So some parts of this data is shown in a gray color in this side, and those are the areas that do not have any values. Values that we are trying to calculate are within this map of Texas, and so that's what we're trying to determine on using gdal. So we've assigned, in order to get the number of layers or bands of this data, we assigned band and use the code get raster band as a band that shows all the layers of this data, and NLC array is going to array that all the data as a numpy array. And so this is the result of the array over here. We determine the maximum and the minimum values of this data as minus 128 and 95. And over here, we're trying to derive the unique values, the unique class and values of those data, and also count them. And so we use this particular function npy.unique array and return underscore count equals true. This is going to help to show all the class of the layer and the corresponding value of each layer. At this point, I'm going to have my colleague Dan explain the results of this project.
Thank you, Edimola, for briefing the statement problems and the early access. Now we go on to the results. So as a result, there are the pixels which is represent the value for each class. So we just find out. So we make the dictionary out of the all the classes, unique classes, and their counts. So that represent the pixels, the number of pixels. So now we run a loop to get the 81 and 82 class, because 81 and 82 class represent the cultivated area in the Texas. So the pixel value of class 81 and 82 are calculated area. So we need to get the number of pixels for that class. So we need to run a loop to get the class area out of that, and the total number of pixels is this is the number. This is the number which is the total number of pixels. So we can the resolution of the one pixel is 30 by 30. So we can multiply that with the pixels, then we can get the areas. and multiplying by the 3.8610 into 10 raised to minus 6, so we can get the square miles. So this is the value of cultivated area in square miles in Texas. Now we have to plot the we need to plot number of pixel versus area, number of pixel versus the class. But there's this value minus 128 and 0 in this dictionary shows the no data value, so we need to delete that because it is unnecessary, totally unnecessary. So by this formation we can delete this. Then we plot the class versus number of pixel. This is look like this. So highest number of pixel is class here, it's class something 51 or 52 something. Okay, then we can plot another graph that is area of each class. So we can multiply this dictionary by a constant number that is 900, which is 30 by 30 again, the resolution, and need to convert into the square miles. So this is the dictionary which is we need the necessary class like 11 to 95, and the value of the area is in square miles, and we can plot the graph from that. So it is the graph of class versus the area in square mile. And now we can get the by adding this all values of all the classes, we can get the land area, total land area of Texas. So here we can see this is the total land area of Texas in square miles, and we can calculate the percentage out of it by dividing the each value of the dictionary by the area of Texas, total area of Texas, so we can get the percentage. So these are the values for each class of percentage area of each class, and we can plot that so this is the plot for class versus area percentage. Now, the finding we can conclude that this is from this we can find out that 22.15% of Texas total land is under cultivation. So cultivation area is 22.15% of the total Texas land area, so which we are finding, and the shrub covers the maximum of 40.93% of the total area of Texas, while barren land only covers 0.33% of the total area. As we can see here, that's 14.93, that is class 52, and that 0.33% is here 31, class 31. So this is our conclusion, and we find this proper solution to our problem statement. And thank you for watching our video.